Welcome students to the second module on functions. In the previous module, we have seen the definition of function, the domain, range and codomain of a function. We have also seen different standard functions to be understood, the graphs, what composite functions are and what inverse functions are, and we have also seen how to add, subtract, multiply and get the quotient of two functions. So these are some things which I have learned in the first module. So I really hope you have understood all these topics. Now in this topic we'll go into a very important topic called the vertical line test to determine if a relation is a function or not. So we have already seen the definition of a function. So what is a function? If a relation f is defined from A to B, a relation f will be called a function if and only if every element in the first set has a unique image in the second set. So this is the definition of a function. If a relation satisfies this condition, then it is called a function. A relation from A to B is a function if and only if every element of A should have a unique image in B. So A is the domain and B is the codomain. So now let us take a sample example and let us check whether that relation is a function or not. So let us say that f is defined from the set of real numbers to the set of real numbers, and the definition is f of x is equal to x square. The image of x is equal to x square. So if you take a relation, right now this is a relation, we'll check whether it is a function or not. So the first set is the set of real numbers and the second set is also the set of real numbers. And if you have any element x here, the image of x is x square. So usually the image of x is also denoted by y. So I can also write this as y is equal to x square. So because we denote this by the ordered pair x comma x square, and if you plot this on the Cartesian system, this x square will be the y coordinate. Hence we call y is equal to x square. This also is exactly same as f of x is equal to x square. Now how does the graph of this look like? So we know the standard graph of y is equal to x square. So you can directly draw the graph if you already know how the graph looks like. Otherwise, you can take a sample table. You can form a sample table, x values and y values. And once you have a sample table, you can get the graph. So y is equal to x square. I am drawing the graph which I know. So y is equal to x square is a parabolic curve. Now is this a function or not? How do we check? So as we know, this function is defined from real numbers to real numbers. So we know that the first coordinates represents the x coordinates. The elements in the first set represents the x coordinates of the point. The elements in the second set gives the y coordinates of the point. So that means x-axis contains the elements of the domain, y-axis contains the elements of the codomain. So x-axis contains elements of the domain, y-axis contains elements of the codomain. Now the domain is all real numbers. So now what I need to check is, corresponding to every point on the domain, do we have one and only one image in the codomain? So as you can see, correspond to this x, you have this y. Correspond to this x, you have a y. Correspond to this x, because this graph goes up and up, you'll have somewhere you'll have a point correspondent on this graph, so you'll have a y. Correspond to every negative value of x, you have a y. You have a y. You have a y so on. So corresponding to every value of x. So if you draw a vertical line, the point where the vertical line from this point cuts the graph is the point corresponding to this x. So if the vertical line cuts the curve only once, that means corresponding to this x, you have only one y. Suppose that this vertical line cuts the curve at more than 1 points. That means that corresponding to this x have more than one y, because corresponding to each point you get a value of y. So if a vertical line drawn from any point on the domain cuts the curve at exactly 1 point, that is good. If it cuts at more than 1 point, that means that for the particular value of x, you have more than one value of y, which is not good. It should not be there for a function. And corresponding to, if this line does not meet this curve, if this vertical line do not meet this curve, if it does not meet this curve, what does it mean? It means corresponding to this x, there is no y. That means this x do not have an image in the second set. That is also not good. So every element should have one and only one image. So this particular relation is a function, because wherever you draw a vertical line, because this is a graph which goes on going up and which goes on extending outwards. So every vertical line will cut the graph at exactly 1 point, hence it is a function. For example, if you take another function, f is a function defined from real numbers to real numbers again. This time I say that y square is equal to x. If this is the relation, y square is equal to x. So we know that the graph of this looks like this. It's a horizontal parabola. So does this relation represent a function? Does this relation represent a function? The answer is no. Because if you draw a vertical line from any point on the positive x-axis, it will cut the graph at 2 points. That means corresponding to this x, I call it x1. Corresponding to this x1, you have a point x1, y1, you have a point x1, y2. That means corresponding to this x1, you have two images. That means if you draw the diagrammatic form corresponding to x1, you have two images y1 and y2. So this uniqueness has been compromised. So this is not a function. And also, if you go to the negative side of the domain, because it's given that the domain is real numbers. If you go to the negative side and draw a vertical line, this vertical line do not cut the curve. That means corresponding to this x, there is no y, which is also problematic, because that means some elements in the domain are left out without an image. So more than one image is also problematic. No image is also problematic. Hence this is not a function. So let us try to understand the vertical line test for a function. So what does the vertical line test say? So any vertical line drawn from any point on the domain, that means from any point on the domain on x-axis, a vertical line drawn from any point on the domain should cut the curve at exactly 1 point. So if this condition is valid, then it is a function. If not, it is not a function. I hope this is clear. Now let us go forward and analyze this statement.